What's up, math fans? I hope you already saw my video on sequences, and what I'm going to do with sequences is now turn them into a series. So what's the difference between series and sequence? Well, a sequence is a collection or a set. I think I used the word in my last video, a set of numbers with, hopefully with a pattern. Doesn't have to be a pattern, but a series is the sum of a sequence. It's the sum of the numbers that were in that sequence. So a sequence in a series looks very similar, except I just added plus signs in between my terms instead of commas in between my terms. Now, arithmetic is the important part because arithmetic means there's a pattern. And I mentioned all this already, so I hope you're comfortable with this. If you're looking at an arithmetic sequence, that means to get from one term to the next, you either added or subtracted the same number each time. That same number each time, a lot of people discuss as the rate of change perhaps. I'm going to call it a common difference, and we use the variable d to represent that. Okay? So then I explain the difference between recursive and explicit. Recursive explains how you get from one term to the very next term. So in order to get to a term, I have the previous term plus the common difference. Okay? So that means going from one term to the next. That's what all of this looks like really high, complicated math. It's not, it's really easy. It's just the notation. So if you're listening to what I'm saying, hopefully it makes it easier. So to get to one term, I have to be at the term right before it. That's what the n minus 1 is. The term right before it plus d. D being the common difference, how you get from one term to the next. Explicit, however, I don't have to go from term to term. I can just jump to any term in the set of numbers. And in order to get it to a specific term, I just need a formula. So my formula is any term is equal to the first term of the series plus n minus 1 times d. And I explained that in my other video what that means. Okay? Here is a new formula, and this also is common sense. If you're not sure what the common difference is, just take a number and subtract the previous term. Take a term, subtract the previous term. So if I wanted the common difference for this, I could just do 6 minus 5. That's it. A sub n minus a sub n minus 1. This number minus that number, 6 minus 5. So here, my common difference, d equals 1. All right? Here, what is this? That's the sum. This right here, this E-looking thing, is really a Greek letter called sigma, and it means sum. It means add up all the terms in the series. All right? And again, everything I'm saying is going to be specific today for only arithmetic series. We'll move on to other kinds of patterns where maybe you're multiplying or dividing. Those are called geometric series. So quickly, can you add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 all the way up to 10? Add them up. You should get a sum, and that would be the sum of the series. That would be sigma, or S of n if you wanted. And here's a formula to do it. I'm going to explain where the formula comes from. So I'm thinking about adding a bunch of numbers in a row, and in order to do that, there's a bunch of different ways you can do it. You can just physically add them all up one at a time, 1 plus 2, and then that plus 3, and then that plus 4, etc., etc. You can get a calculator, of course. You can start to add the ends, and notice the ends match. 1 on that end plus 10 on this end is what? 11. 2 plus 9 is what? Oh, also 11. No coincidence there. 3 plus 8 is also 11. No coincidence there. So then you're just adding pairs of 11. All you have to do now is know how many pairs of 11 there are, and you'll see how many. There's another way to explain this, and I'm going to show you where the formula comes from. I'm going to add the same numbers, but backwards. 10 plus 9. I messed that up, didn't I? 6, 5, 4, 3, 2, 1. So this row represents the sum of the terms, of all the terms, all n terms. This row also represents the sum of the terms. Just because I wrote it backwards, you're still going to get the same sum, whatever that is. Now I'm going to add straight down. Giant plus sign, add straight down. What do you get here? 11. What do you get here? 11. What do you get here? 11. So each pair is going to give you 11. So I'm going to get 11 plus 11 plus 11 plus 11 all the way down to the last pair, which also gives me 11. And that equals S sub n plus S sub n is 2 S sub n's. So, how many 11s are here? If I wasn't lazy and didn't do dot 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 and actually listed them, how many 11s are here? Let's see. 1 pair, 2 pairs, 3 pairs, 4 pairs, 5, 6, 7, 8, 9, 10 pairs of 11. 10 pairs of 11 equals 2 S sub n. Alright, so 10 times 11 is 110 equals 2 S sub n. Divide by 2 on both sides, and my sum, the sum of the original list of numbers, is equal to half of this, which I hope is 55. Is it not? I sure hope it is. Alright? And this is really, I just did this the long way just to explain the formula. There's a formula here. It's right here. What it is where does the number 11 come from? It comes from the first term plus the last term. That's what this is, right? Making sure you can see it. And where does the n over 2 come from? Well, n is the amount of terms there are. And I said that in my last video. So there were 10 terms, but then you have to divide that by 2 because of this 2 right here, this 2 right here where I divided by 2. So that explains where this formula comes from. Then you don't have to really worry about all this extra work. You can just go straight to the formula. So if I need the sum of these, which happens to be n equals 1 all the way to the first term to the 10th term, and by the way, the direct formula here, I hope you know, is just plain old n, and it's usually not that easy. So that equals to, well, let's see here, 10 over 2 times 1 plus 10, right? N over 2, a sub 1, a sub n. First term plus last term is 11. There are 10 terms. 10 divided by 2 is 5. And again, my sum is 55. Don't panic, but you should have a good question. What if there's an odd number of terms? That's okay, it still works. Pick one, make up one on your own, and try it. All right, let's look at number 2. First of all, this here, the given, is the explicit formula. It represents every single term in a sequence. How many terms are you expecting? 5 terms. Oh, an odd number of terms. Oh, let's see what happens. First term is when n equals 1, so I'm going to plug in 1 right here. Negative 3 times 1 plus 1. I think I did this in my last video, so you're already comfortable. Negative 3 times 1 is negative 3, plus 1 is negative 2. That's my first term. The next number is 2. So negative 3 times 2 is negative 6, plus 1 is negative 5. The next number is 3. Negative 3, I feel like I'm playing bingo here. Negative 3 times 3 is 9, plus 1 is negative 8. And if you saw my last video, we finished this is actually a sequence, but it should be a series, so I'm going to change it in a minute. The next term would be negative 11, and then the fifth term would be negative, what am I going up by? 3, and then 3, and then 3. So this one's going to be negative 14. All right, that's how it would look as a sequence. Here's how it would look as a series. What did I do? I just showed you that I'm adding them. That's all. That's the only difference between sequence and series. Now, quick, add them. All right, you can do it the long way, or you can use the formula, which is 1, 2, 3, 4, 5 terms divided by 2 times the first term plus the last term. So this is 2.5 times negative 16, and whatever that gives you. I believe it gives you negative 32, and another 8 is negative 40. But please, please, please check my work, because I just did that in my head. Okay? So there's a bunch of ways to think about this. You can also just add in this plus this, and then this plus this, and then add negative 8 at the end. Same thing, you should get negative 40. Okay? So I use my summation formula here. This and this mean the same thing. This is the sum, this is the sum. Okay? Remember, this sequence and this series, in order to get from one term to the next, you're adding 3. That's how you know it's arithmetic. So this formula that I've given you only works for arithmetic. If it's not arithmetic, sorry, no shortcut. There is another way to do it, and I will work on that one in the next video. Thanks for watching. See ya.